Question number 3. A is ABC. Write down the minimum number of ordered pairs. So reflexive. What are the elements of the set A? ABC. What you should have? AA, BB, and you should have CC. CC is not there. So you just write CC should be included to make it reflexive. That's a minimum. What about your symmetric? Tell me, for symmetric what should be added? Symmetric. To make it symmetric, we should add C. AA is there. We have to come here now for the relation. AA, BB, AC is there. CA should be added. Transitive, do you have anything to be added? Check. AA, anything starting with A? Yes. AA. Now you have to see AC is there. BB, is there anything starting with the B? Nothing. Only BB is there. AC, anything starting with the C? No. So if it is not there, whatever is there you check, that's it. So nothing to be added. To make it an equivalence relation, you should add CC, we have to add, then CA. These two should be added. The fourth one, let P be the set of all triangles in a plane. So P is a set. Here P is given a set. What is a set P? All triangles. All triangles in a plane. So you know you have infinite number of triangles. What is the relation? If A is related to B, what is the condition? Only if A is similar to B. Is it reflexive? How do you check whether it is reflexive? Reflexive means you have to check with the same triangles. Now if I name this as A, this as B, and this as C, is A similar to A? A triangle is similar to itself. You have learned that? Yes. A is related to A because A is similar to A itself. Now, is it symmetric? Suppose you take two triangles. If you say A is similar to B, then B will be similar to A, isn't it? A is similar to B. A similar to B means sure B will be similar to A. So this implies B is similar to A. Therefore, it is symmetric. What about transitivity? To prove it is transitive, you need three triangles. You just take ABC. If A is similar to B, start with B now. If B is similar to C, then A will be similar to C. Then A is similar to C. So A is related to B, B is related to C, and A is related to C. Therefore, it is transitive. Therefore, it is an equivalence relation. The next one, on the set of natural numbers. So the set is natural numbers here, and they have defined a relation R. What is the relation? A is related to B. What is the condition? If 2A plus 3B equal to 30. That means A and B are related such a way, when you multiply A into 2 and B into 3, it should give you 30. Only those numbers, those ordered pairs we have taken. So let us find A and B. The condition is 2A plus 3B is equal to 30. So we can write this 2A as 30 minus 3B. So A will be 30 minus 3B by 2. Now see, it's a set of natural numbers. So we cannot have odd number in the numerator. If you have an odd number in the numerator, when you divide, you won't get the natural number. You should get a natural number. So B, you cannot give odd numbers. If you give B as 1, what do you get? 30 minus 3, it's an odd number, isn't it? If I give B as 3, you get an odd number, 30 minus 9. If you give B as 5, you will get an odd number. I am not taking the odd numbers. The reason is A will become a fraction. When A is a fraction, it is not a natural number. A should be taken as from the natural numbers. So let us give values for B. Start with 1 we can't give. So start with B as 2. Put B as 2. What is A? 30 minus 2, that is 6. by 2. 24 by 2, 12. Okay. Now take B as the next even number, that is 4, 9. Okay. A is 9. Okay. Now give B as 6. 6. You get 3 into 6, 18. 30 minus 18 is 12 by 6. Okay, fine. B as 8. What is A? 24. 30 minus 24 by, that is A is 3. Give B as 10. What do you get? 30 minus 30 by 2. A as 0. Is A 0 a natural number? No. After that you get negative numbers only. After B, if you give 11, you all will get negative numbers. 0 itself we can't take. So this is not included. Let us omit this. So what are the ordered pairs? Now you write the relation. So A is 12, 2, 9, 4, then 6, 6, and 3, 8. So these are the elements: 12, 2, 9, 4, 6, 6, 3, 8. Now you check whether this is reflexive. What is a reflexive relation? Why? One example. When you say no, just give one example. One example from here. When A is 12, see, you know the elements now. A is 12. Do you have 12, 12? That is, if you take 6, 6, 6 should be there. If I take 12, 12, 12 should be there. If I take 9, 9, 9 should be there. But it's not there. Every A belongs to A. You should have A, A in R. But it's not there, isn't it? 12, 12 is not there in R. Therefore, not reflexive. So, just by seeing 6, 6, don't say it is reflexive. Is it symmetric? Is it symmetric? Why? Give one example. When you say no, one example. Now, when I take 12, 2, 12, 2 belongs to R. Is 2, 12 the odd reverse pair? 2, 12. Is it there in R? No, isn't it? One example you give, it is enough. So it is not symmetric. Next is transitive. Now, transitive, we should be very careful. Now you take 12, 2. Now you have to check 2, anything starting with 2 is there? No. So we can omit this. Now 9, 4. Anything starting with 4? No. If it's 6, 6. Anything starting with 6? No. 3, 8. Anything starting with 8? No. If the condition is very important. If A, B and B, C belongs to R, then you have to check. Only then we can check for transitivity. If this condition is not there, we cannot check for transitivity. We cannot prove that it is not transitive. So it is taken as transitive. Therefore, it is transitive. It is not an equivalence because it is not symmetric. Reflexive and not, but it is transitive. Okay.